So we'll be learning about the Ardens theorem. So learning objectives to understand the basic algebraic properties of regular expressions and to use the Ardens theorem for conversion of a given DFA to RE, that is a regular expression. So what is Ardens theorem? Ardens theorem is popularly used to convert a given DFA to its regular expression. So Ardens theorem is popularly used to convert a DFA. DFA is a deterministic finite automata to its regular expression, to its RE. It states that let P and Q be two regular expression over an alphabet. If P does not contain a null string, then R is equal to Q plus RP has a unique solution, that is R is equal to QP asterisk. So proof is R is equal to Q plus RP, R is equal to Q plus RP into P, R is equal to Q plus QP plus RP square, R is equal to Q plus QP square plus QP cube. So we say that R is Q common, you take epsilon P square plus P cube. So we say R is equal to QP. So Ardens theorem, to use Ardens theorem, following conditions must be satisfied. The transition diagram must not have any null transitions. So you should not have any null transitions for Ardens theorem to be satisfied. There must be only a single initial state. So only one initial state will be present. Final states can be many, but initial state will be only one. Conversions of DFA, that is a deterministic finite automata, to a regular expression. Step number 1, form an equation for each state considering the transition which comes towards the state. Add epsilon in each equation of the initial state. So for initial state we will be adding epsilon. Step number 2, bring the final state in the form of R is equal to Q plus RP to get the required regular expression. When you bring it in the form of R is equal to Q plus RP, you get R is equal to QP asterisk. So conversion of DFA to RE, what is a note? Ardens theorem can be used to find a regular expression for both DFA as well as NFA. So you can use Ardens theorem for a deterministic finite automata as well as for a non-deterministic finite automata. If there exist multiple final states, then write a regular expression for each final state separately. So there can be multiple final states, so we will write regular expression for each final state separately. But your initial state will be only one. Add all regular expressions to get the final regular expression. So let's see an example. Find the regular expression for the following DFA using Ardens theorem. So here A is the initial state, here A is the initial state and B is the final state. So first initial state, in initial state we saw note that you have to mention epsilon. So we'll write here A is equal to epsilon plus B, because it is going towards A, 1 is going towards A, so B into 1, and B is equal to, that is a final state, A, 0 is going towards B, so A into 0. Next step is bring the final state in the form of R is equal to Q plus RP. So final state is what? B. So B is equal to A into 0. So we will substitute this equation 1. So A we will put over here. So we write B is equal to epsilon plus B into 1 into this 0. So we have substituted this A inside the B. B is equal to epsilon into 0 plus B into 1 into 0. B is equal to epsilon into 0 will be what? 0. So we write 0 plus B into 1 into 0. So this equation has come in the form of R is equal to Q plus RP. So we will write R is equal to QP asterisk. R is your B, Q is your 0, Then again R is B and this is P. So R is equal to Q is 0. P is 1 into 0 asterisk. So this is your regular expression. Next question says, draw a state diagram and construct a RE corresponding to the following transition where Q1 is the final state. Now how do you draw a state diagram? We will see. Q1 is the final state because it is Q1 asterisk. So we say that Q1 is the final state. Q1 on 0 goes to Q1 itself. So we'll write here Q1 on 0 goes to Q1. Q1 on 1 goes to Q2. Next Q2 on 0. Q2 on 0 goes to Q3. Q2 on 1 goes to Q2 itself. Q3 on 0 goes to Q1 and Q3 on 1 goes to Q2. So this is the state diagram. State diagram. So this is what is drawn over here. So we'll write Q1 is epsilon plus Q1 into 0 plus Q3 into 0. Q2 is Q1 into 1 plus Q2 into 1 plus Q3 into 1. Q3 is Q2 into 0. Step number 2, you will substitute. So take equation Q2, that is you will take equation number 2. From equation number 2 you will get this. Now this 2 you will be putting in 1. See, you got this 1. Q1 is the final state. So you get regular expression as this. Let's see the next example. Find regular expression for the following DFA using the Ardens theorem. So you will be given a DFA. 3 equations will be Q1 is their initial state. So epsilon plus Q1 into A and Q2 into B. Q2 is Q1 into A because A is moving towards Q2 and B is also moving towards Q2. So Q2 into B. Q3 into A. Q3 is what? Q2 into A. Step number 1 is done. Step number 2 says substitute Q3 in the equation Q2. So we substitute Q3 in Q2. So instead of Q3 into A, we'll write Q2 into A into A. So you wrote Q2 A into A. So Q1 into A plus Q2 into B plus Q2 into A into A. So Q2 equal to Q1 into A plus Q2 into B plus AA. Now this is in the form of R is equal to Q plus RP, where R is this, Q is this, again R is this, P is this. So we can rewrite in the form of R equal to QP star. How will you rewrite? R is Q2, Q1 into A, B plus A into A star. So you got this. This is equal to Q2. Now substitute Q2 in Q1. So here Q1 we will be writing. Q1 is what? Q1 is epsilon plus Q1 into A plus Q2 into B. So Q2 into B you will substitute. Q2 into B, instead of that you will write this into this is your B. This is your Q2 into B. So you get epsilon plus Q1 into A plus A times B plus AA asterisk into B. So Q1 you got it in this form. So now this is in the form of R is equal to Q plus RP. So R equal to QP asterisk will be Q1 equal to epsilon will be 0. So we'll write A plus A, B plus A asterisk into B. This is your Q1. See, Q1 you got this. If you want to write this epsilon, you cannot this. You can ignore also. Q2 also we have got. So Q3 will be what? Q3 is equal to Q2 times A. It was Q2 times A. So Q3 will be Q2 times A. But what is Q2? Q2 is this part. So copy this as it is times A. Since Q3 is the final state, the set of strings recognized by the transition graph is given by this. So RE is equal to A plus A into B plus AA asterisk B whole asterisk A B plus AA asterisk into A. Next question is find the regular expression for the given DFA using Ardens theorem. So step number 1 says, we'll write here Q1 equal to epsilon plus nothing is there, so 0. This is my equation 1. Q2 equal to, Q2 will be Q1 into A because A is coming towards, that's it. Q3 will be Q1 into B because B is going towards, Q1 into B, Q2 into A plus Q3 into A. So you got this. This is what? This is step number 1. Step number 2, you will substitute. How will you substitute? Q1 equal to epsilon is given. So we'll write Q2 is equal to, Q1 is what? Epsilon into A. So Q2 will be nothing but equal to A. If Q2 is equal to A, then Q3 will be equal to Q1 into B will be epsilon into B plus Q2 into A will be A into A because Q2 is A plus Q3 into A. So my Q3 will be B plus AA plus Q3 into A. This is what? R is equal to Q plus RP. We can write this as R is equal to QP asterisk. So Q is B plus AA into A asterisk. So this is the, we wrote this B plus AA into A asterisk. Let's see the next question now. Find the regular expression for the following DFA using Ardens theorem. Now you have 2 final state and 1 will be your initial state. So Q1 will be epsilon plus Q1 into 0. Q2 will be Q1 into 0. Q2 will be Q1 into 1 plus Q2 into 1 and Q3 will be Q2 into 0 plus Q3 into 0 plus Q3 into 1. So that is what they have written. Now you have this. This is already in the form of R is equal to Q plus RP. So Q1 is 0 star. Q2 is what? Q2 is given as Q1 into 1 plus Q2 into 1. Q1 you have already got as 0 star. So we'll write 0 star into 1 plus Q2 into 1. This is in the form of R equal to Q plus RP. So we can write it as R is equal to QP asterisk. R is what? Q2 is equal to Q is 0 asterisk 1 into P is 1 asterisk. So this is your RE. So Q2 is what? 0 asterisk 1 into 1 asterisk. So this is what? This is the Ardens theorem.